it going, everyone? My name is Sean Moriarty. This is my second ElixirConf USA. I was here last year. It's actually super exciting to see the number of machine learning talks. I think in 3 years, we've gone from Jose doing the initial NX demonstration at Codebeam to now, there's like double-digit machine learning talks. So it's been pretty awesome to see the ecosystem grow. I'm going to be talking to you today about simplifying machine learning operations and machine learning deployments with Elixir. And the alternate title for this, as I told Jose, was my love letter to NX serving, because I think Chris McCord mentioned it briefly, but it is an absolutely fantastic abstraction for deploying machine learning models. Before I get into it, I have to do this disclaimer. The views expressed in this presentation are that of the speaker and do not represent the views of the United States government, Department of Defense, or Army Cyber. Okay, so with that out of the way, a little bit about myself. I am the author of Genetic Algorithms in Elixir. That is the book that kind of sparked the NX and the machine learning work in this Elixir ecosystem. More recently, I actually published Machine Learning in Elixir, which is a book on how to do machine learning with NX, Axon, and some of the other projects we have. My friend Andres actually mentioned to me last night, despite this book getting published, that there are still no good resources for machine learning in Elixir in the ecosystem. So use that for your decision to buy it or not. If you want to follow me, I have a Twitter right there, Sean_Moriarty. I tweet a lot about Elixir and then also a lot about Philadelphia sports. I'm a huge sports fan, so you might get some of that mixed in with some of my traffic. Yeah, yes, sir. So in this position, I've been working in the NX and Elixir ecosystem for about 3 years now, and I'm always asked two questions. The first is, should I write my startup, side project, or new app or whatever in Elixir? And then the second is, should I use Elixir for my machine learning project? And I generally have one answer to this, and I think this is the best answer, is that you should just do whatever you want. I think I've found that programmers are not rational people. Despite how we would assume to be logical, programmers choose things for aesthetics over logic almost every time, 9 times out of 10. So the best answer to that question is to do whatever you want. Now the second best answer to that is yes, you absolutely should use Elixir for your startup and for your machine learning project, and I'm here to tell you why. Elixir allows you to be your own one-man army. So in this ecosystem, we have Phoenix, you can develop web applications. We have Nerves, you can develop and target embedded systems. We have NX, you can build machine learning applications. Now with LiveView Native, you can target iOS development and native devices. There's so many things you can do and just live in the same stack. And it honestly allows you to punch above your weight. So you have a small development team that's able to target a ton of different ecosystems. This is an example of just that. So this is a tweet from Dave Lucia, and I asked him for permission to share this, and he said as long as I shared his typo that he was okay with it. But this is a team of 2 developers shipping incredible things. And I've seen this firsthand as well. There's a lot of small teams out there. A good example, Teller, small team of about 13 people, and they're shipping some pretty incredible things pretty quickly, and it's all because of the language. But this is not an Elixir rant. This is an Elixir machine learning rant. So let's get into this machine learning question. I think a better question to ask is, how can Elixir help me build machine learning applications? And this is, so the first thing I want to do is I want to take a look at what the current machine learning landscape is. So I apologize for how small the text is, but that is kind of intentional because this is a graphic that demonstrates what the current machine learning, AI, and data landscape is. And you can see it is like a massive hodgepodge of tools for different applications and different things you can do. But what if we could take this stack and we could simplify it into this? Now, I'm not naive enough to admit, or I'm not naive enough to say that you can solve all of your machine learning and AI and data science problems just with Elixir. Elixir is not a silver bullet, but I am here to tell you that Elixir can simplify a lot of things, unless you can just use Elixir for everything. I will argue that Elixir simplifies some aspects of machine learning deployments, and specifically, I think Elixir simplifies a lot of the inference and serving aspects of your machine learning deployments. We are a relatively young ecosystem, so we don't necessarily have all of the things you would find in Python and some of the more mature ecosystems out there, but we're very, very quickly catching up. In the past year, we've released reinforcement learning libraries. We have Bumblebee. We've done a lot of things to sort of close the gap between ourselves and the Python ecosystem. So let's get started. What is machine learning operations and why does it matter? Machine learning operations is this all-encompassing process of deploying machine learning models to production. And the reason it matters is because machine learning models are not meant to die in a notebook. The reason we train machine learning models is to solve customer problems, is to solve user problems. I do think it's funny when you have these machine learning tutorials out there that basically end when the story starts. So you finish with a trained model in a notebook, and then it's like, well, where do I go from here? And that's kind of the biggest question, is how do I get this model over the wall from this notebook into production? Machine learning ops kind of encompasses that entire process, going from raw data, doing an exploratory data analysis, making the decision whether or not to use machine learning, all the way to deploying my model and then continuously updating my model, because in production these models drift. In the Python ecosystem, these are the tools that kind of cover this entire process. So you can see a lot of them are libraries, but there are also a number of I would say enterprise machine learning operations services, because the tendency in that ecosystem, I think, is to reach for an external tool or an external service rather than live in the language. And I think in Chris McCord's keynote, he made a great point that in Elixir, there are a lot of small but powerful things that allow you to build up these really incredible features. Now, this is what the machine learning ops process might look like in Elixir. You'll notice I have some question marks in there because we're still kind of filling in the blanks of how does this work in a production environment. We're mostly going to spend a lot of time talking about NX serving, because I think NX serving is a really powerful thing. And I think it's something that more people should try to use and more people should appreciate. I would like a quick show of hands. How many people are actually using NX in production or considering using NX in production? It's also hard for me to see, but it does seem like there's a number of people out there, and hopefully after this talk I can convince you that you should consider it at least. All right, so let's pretend we're designing a simple Twitter-like application that we're going to train some machine learning enrichments around. So this is my unveiling of my Twitter clone called X, EX, ElixirConf USA 2023. And I would like to caveat this, that I am not a very good web developer. It took me a very long time to actually use Phoenix. I do have some good Phoenix in production stories, so after this talk, if you want to talk to me, I think I have some funny ones. But this took me, I would say, like a couple minutes to stand up. And that was pretty awesome to me because, like I said, I'm not very good at this stuff. But it took me 5 minutes to get this going with some real-time updates. And of course, because this is Elixir, X needs to have some sort of real-time component. So I went out and I decided, well, I got to use PubSub. I'd never used PubSub before, and after implementing it here, I was like, why have I never used PubSub before? It was super easy. So X is this real-time Twitter clone. Now, let's say that for whatever reason, we want to analyze the sentiment of some of our posts. So we might want to, say, flag negative posts, have them get reviewed, or we want to measure the overall sentiment of what people are saying on the application. So how can we do this? Well, one thing we can do is we can take advantage of Bumblebee's pre-trained models. Bumblebee is a library for accessing pre-trained models and tasks or servings with Elixir. So here I'm implementing a Bumblebee serving that does sentiment analysis. So I load this model, which is a sentiment model, and then I pass it to Bumblebee's text classification task. And now that is going to actually take care of the entire process of pre-processing input text to doing inference to actually mapping that to a label. And then I can take that implements the NX serving data structure, because what NX serving is essentially just a data structure that tells me, hey, how do I want to implement pre-processing, how do I want to implement inference, and how do I want to implement post-processing? And then I'm going to pass that to my application supervision tree. So this is a child spec for NX serving, and I'm passing in a name that I'm going to use to reference that process. And then I pass in my serving, and then I pass in a batch size and a batch timeout. Now, the batch size and batch timeout are relatively important arguments that I'll talk about in a little bit. But that's really all it takes to actually get this sentiment analysis model up and running. So you can see that's about 30 lines of code, and here I am actually demonstrating that it works. So ElixirConf is awesome, and that's positive, and then PythonConf is not so awesome. I don't think that's actually the name of the Python conference. So, but it took me 30 lines of code in about 5 minutes to get the machine learning model running in my Phoenix application. Now, that's cool, but why is that better than just calling a function? Why can't I just implement my own pipeline for tokenizing some text, calling axon predict, and then mapping that to a label? Well, we can design our inference pipelines so they're not concerned at all with concurrency. The way NX serving works is it implements dynamic batching. So in the world of accelerators, GPUs and CPUs, with we have SIMD instructions and all of these things that can take advantage of vectorization. Doing inference at batch size 1 is incredibly wasteful. So you can imagine if I have a ton of users connecting to my application at once, and they're all posting at once, and I'm trying to do a single prediction on all of these at once, I end up wasting a ton of resources because I'm doing a prediction on one, doing a prediction on another, and then I end up queuing all of these posts without actually taking advantage of the resources I have. There's a lot of overhead with transferring data from the CPU to the GPU. So in order to avoid starvation, we actually have to send these in batches. So that batch size and batch timeout that NX serving takes as an argument in that child spec actually are the arguments for controlling that dynamic batching. So for example, if I indicate that I want to use a batch timeout of 50 milliseconds, my NX serving process is going to wait for 50 milliseconds to fill my batch and then perform inference on that entire batch at once. So in that case, I'm not wasting any resources at all. I don't have to worry about doing batch or inference on batch size 1. And the cool thing is that actually takes care of the concurrency for you. So let's say we want to add an async named entity recognition enrichment component. Named entity recognition is just a text natural language processing task where I essentially pull the proper nouns out of a sentence. And for whatever reason, I want to add that to my application. So here I have my Bumblebee serving as well. It does a token classification. I specify that I want to compile this with EXLA and whatnot. Now, I want this model to run in the background after posts are published. So there's a lot of ways I could do this. I could use the task module. I could use live use new async, assign async, a separate process, or pretty much any of the thousands of ways, exaggeration, that I can do asynchronous processing in Elixir. Now, you can imagine if I had a bunch of people posting at once and I was spinning up hundreds of async processes, it would be kind of a nightmare to manage myself to try to get these processes batched. However, with NX serving, it just takes advantage of takes care of the batching for me. So each one of these asynchronous tasks that I spin up will actually use that same queue. So I'll end up with hundreds of asynchronous processes, but they're going to be utilizing the GPU all the same. So the bottom line is that it doesn't really matter. I don't have to worry about concurrency when I'm working with NX serving. This is an example now of my NER task. So you see, I post here, Sean is in Orlando, and then I have my entities up here, and I see a personal location that show up there. So you can see now how NX serving is a relatively simple abstraction, but it's a very scalable abstraction. It's something that solves a lot of problems, a lot of complicated problems for you just out of the box. Now, the so what of NX serving is that dynamic batching handles concurrency for you. So as I mentioned several times, you don't have to worry about starving your GPU or your accelerators. It's something that is almost infinitely scalable. The other thing is that it encapsulates pre-processing, inference, and post-processing for you. So when I implement a serving, I take advantage of, or I map, the real-world process of, let's take a real-world input, and then I map that to a real-world output. When I'm working with a machine learning model, a lot of times I'm dealing in tensors, and that doesn't necessarily map to a business use case. But NX serving maps that entire end-to-end cycle for me. It can also target any NX backend or compiler. So NX serving is really just a behavior or a data structure. I don't necessarily have to marry it to something like EXLA. So for example, there's an open PR in the NX repository right now for the CandleX backend, which is a Rust backend that is powered by the Hugging Face Candle library. So if I have some other backend or some other accelerator I want to use, then I can implement my own behavior. I can implement my own NX backend or compiler. Another good example is we have something called Ortex, which is a storage-only backend in NX that runs for the Onyx runtime. So if I have open neural network exchange Onyx models that I want to deploy, I can essentially just wrap those in an NX serving and then use the Ortex backend and then deploy my models that way. So I don't necessarily have to train any models in Elixir. I can just take them from whatever my machine learning or data science team is doing, and then I can wrap them in my production pipeline without having to use a separate microservice. The other thing is that any numerical definition can be wrapped in a serving. And that's something I want to emphasize and re-emphasize because in the Python ecosystem and other machine learning ecosystems, most of the serving tools that they have out there are really specialized to one library. So for example, TensorFlow serving is wrapped to TensorFlow models. TorchServe is wrapped to Torch models. There's not necessarily something that is a generalized serving abstraction. There's Kserve, which is Kubernetes serving, but realistically, a lot of these things are overly complicated. Any numerical definition can be wrapped in a serving. So if I have an Axon model, I can wrap that in a serving. If I have an XGBoost, which is a decision tree type model, I can wrap that in a serving. If I have a traditional machine learning model trained with Scholar, I can wrap that in a serving. It's a unified abstraction that I can work with across any domain of machine learning. The other thing is that you don't actually need a numerical definition to do this. So for example, some libraries, like we have a library in the ecosystem called HNSW, which is a semantic search or is a vector search library, and that actually benefits from batch processing as well. So even though that's not taking advantage of numerical definition, I can actually batch my searches with HNSW using NX serving. So if you have any sort of batch processing that you need to do, you could actually consider using NX serving without having to deal with numerical definitions. Now, of course, nowadays, all anyone cares about is large language models. So the other question you might ask is, well, can I use NX serving to stream generations? And the answer is yes. It's actually just a single line of code change. So here I have a text generation serving x.tweeter, so this will generate a tweet for you. I take a GPT-2 model, which is a tiny variant of one of the earlier GPT models. And then all I do is I pass this stream true right here. And with that single line of code, I get something that looks like this. So all I have to do is click finish my post, and it'll stream my outputs for me. And you can also do this with inputs. So for example, if you're working with Whisper, and this is one of the things that Jose and the team are working on adding is now, I can actually take my audio, if I have a long form audio transcript, like an hour worth of audio, I can actually stream that into an NX serving, and I don't have to worry about chunking that audio transcription manually. So I can do input streaming and output streaming with NX serving. And the other thing is that because this is wrapped in a serving, this is also batched. So if you have multiple people requesting generations at once, all of those generations will be batched. Now, if you have multiple GPUs, can you utilize them with NX serving? So for example, let's say you have 2 GPUs and you want to run the same model on both of those GPUs. Maybe because you have a case where you have to load balance between them, or you have a lot of traffic and one GPU is not cutting it. Well, with a single line of code change, partitions true right there, what that'll do is that'll actually load balance or direct your traffic to both of those GPUs. So you can run across multiple replicas. And then I think as Chris mentioned in his keynote, NX servings are also all distributed by default. So we have some distributed abstractions. You can do some distributed pre and post processing. But if you have NX servings running on all your nodes in the cluster, they're just going to be load balanced for you. If you call an NX serving, call the batch to run the prediction method on an NX serving, it'll look for a node on the cluster that has that process, and then it'll do the prediction for you. So with this very, very simple abstraction, and with only a few lines of code, you get a very scalable, production-ready machine learning pipeline. Now, as I said before, I'd like to really re-emphasize that serving works for any numerical definition. So Axon, Scholar, XGBoost, whatever you can come up with, you can use NX serving for. If you have some specialized machine learning use case, something that doesn't necessarily fit in with what Bumblebee offers or with what Axon offers, you can still use the NX serving abstraction. Now, I've covered serving quite a bit, and there is a lot to cover in the machine learning operations ecosystem. So the next question is, what else can Elixir do for me? I don't really care about serving. Maybe I want to do some exploration on production data. Well, we have this awesome tool now in the ecosystem called Livebook, and I can use something like a smart cell to connect to an external data store. So here I am connecting to my dev database. Using my Postgres password there. Very secure password, I know. That's my password for everything. Then I'm going to use another smart cell to write a query here, and it's going to select everything from my post table, and you can see I get my post back. And I can convert that to code if I want, or I can continue exploring data that way. And now, what if I want to create a chart from that, or I want to do some exploratory data analysis? Well, the cool thing is, with another smart cell, I can actually go ahead and start doing some visualizations. So this is going to use VegaLite, and for anyone that's actually familiar with the Python ecosystem, Matplotlib or Plotly, VegaLite is much more of a pleasure to work with. I'm actually, I think, physically incapable of memorizing the Matplotlib API, and ChatGPT now writes all my charts for me when I use Matplotlib. But VegaLite is very simple. There's a lot of, you build up charts with these simple abstractions, so it's pretty awesome. And I was told by Isaac, I don't know if he's in the audience right now, but if you want to use Livebook, you don't necessarily want to connect to your external data store. He might have a solution for you as well. So there are a ton of ways you can use something like Livebook to, say, connect to your application or connect to your data store to do some of these things like exploratory data analysis on production data or doing some pre-processing or whatever it is you need to do. Another question you might ask yourself is, well, what if I have to label data? So this is a very common problem in machine learning. I would say like 99% of problems in machine learning can be solved by just labeling more data and getting more quality data. And there are a lot of tools out there, enterprise tools out there, where you can spend thousands or hundreds or whatever dollars to get labeling software. Well, it turns out if you just stay in the ecosystem, you can implement labeling tools yourself. So this is an example of a labeling tool I worked with Teller on. And it's basically just a named entity recognition labeling tool that replaces like some $100 enterprise labeling solution you'd find in another ecosystem. And it's a relatively simple implementation as well. It's not something that's overly complex. Like I said, I'm not the best at live view, but this is pretty easy to put together. Now, another thing you might be able to do with Elixir is, okay, well, what if I want to do continuous training? A lot of times, models drift in production. So what that means is new data comes in, and maybe that distribution of data changes over time, or your predictions change over time. So you want to continuously update your model so it serves your users best. There's a lot of things you could do. Maybe I want to use Oban to schedule training runs at periodic intervals, or I want them to trigger after I collect a certain amount of data. It doesn't matter. I can implement something like this, where I have my model training loop. This is just a simple Axon model training loop. And then I can IEX into an application, so I can connect to my application, and then I can actually run a training run. So this is going to run a quick training run for 2 epochs. It'll go pretty quick because EXLA is pretty fast. And then I will get my model parameters back out. And I can use those updated parameters to deploy a new model to production. Of course, I think we can do a lot better than just IEXing into our applications. So what I decided to do instead was, well, let's take advantage of Axon's event handlers. So Axon has this concept of event handlers that run at different times in the training iteration. And as I mentioned earlier in the talk, I just learned about pub/sub, so I decided that I was going to pub/sub everything. So I have this endpoint here that I'm broadcasting updates for my metrics here. And because of that and some live view magic, I can actually connect to my production application and then launch a training run from a live view, and then it'll stream the training progress to a chart right there. And this was like a super simple implementation. This took me, I would say, about 15 minutes to put together, just because of how powerful some of the abstractions we have in the ecosystem are. And this would run for as long as I wanted to. Now, of course, you probably wouldn't want to actually train on your inference node, but the cool thing is, with Elixir, we have this amazing ability to cluster our applications. So I could use something like node.spawn to spin up a training run on a training-only node. If I have a training node in the cluster, or let's say I want to take one of my inference nodes down and use it exclusively for training, and that won't actually interfere with any of the inference nodes, or the load that the inference nodes would be able to take. Of course, there is a lot that I didn't actually cover here. There are things like automatic redeployments that I could do. Let's say I have a dynamic supervisor that's supervising all of my servings, and I'm going to dynamically start and stop these servings. Or let's say I want to replace a serving with a different type of model. So for example, if I have a neural network and then I find that actually a decision tree works better, I could take advantage of hot code reloading to dynamically reload what kind of model I'm serving in production. I could use scheduled or triggered training runs with Oban. There's things like shadow deployments, A/B testing, and other model acceptance things that I didn't talk about. Instrumenting servings with telemetry, so all NX servings emit telemetry events, as well as EXLA emits telemetry events as well. So you can debug different things about your machine learning pipelines in production. There's a lot of ground still to cover in the machine learning deployment space, but I hope this kind of serves as an introduction for what is possible with relatively simple abstractions. And with Bumblebee and some of the libraries we have out there now, you don't even need to be a machine learning expert to get these things off the ground. You can just do these things without really having any machine learning experience at all. Now, if you want to play with this is actually available online, xconf.fly.dev. So here I am. Hello, ElixirConf. This is on a pretty small node, so please don't crash it. And if it does crash, it's not my fault, it's Fly's. And I can also do the typing. So hello, and then it'll finish my post. And oh, there we go. I'm sorry. So great talk, Sean. Thank you, I appreciate it. Yeah, so that's pretty much it. That concludes my talk. Are there any questions?